Okay, guys, this is our last video for the topic of memory, and this is our last video for Unit 3. So after this video, next week you'll have your exam on Unit 3, and we're almost done with the semester. Crazy how fast it went. All right, let's talk a little bit about forgetting. Here we go. So basically, one of the big questions in memory research is why people forget. And this is sort of like the ultimate puzzle in the study of memory. So the first scientific study of forgetting was conducted by a researcher named Hermann Ebbinghaus back in the 1880s. Ebbinghaus wanted to study the forgetting of a material that would be uncontaminated by his previous learning. So he invented what he called nonsense syllables, constant vowel consonant arrangements that do not correspond to words. For example, there are 4 nonsense syllables shown in this array of verbal material. Click on all 4 to move forward. So nonsense syllables, let's see. How about XOF, BAF, MEQ, CLP. Let's see what happens. So Ebbinghaus memorized lists of nonsense syllables. Sounds like he didn't have much of a life. And then tested his memory of these lists after various time intervals. His results were summarized by the famous Ebbinghaus forgetting curve, which graphs retention and forgetting over time. So I'll show you when I click on the various retention intervals at the bottom of the graph so we could plot the famous Ebbinghaus forgetting curve. After 20 minutes, his memory dropped to about 60%. After an hour, to about 48%. 9 hours, to about 38%. About a day later, to about 35%. 2 days, dropped to about 32%. 5 days, a little under 30, and then after a little over a month, dropped down to about 25%. So, as you can see, Ebbinghaus's famous forgetting curve showed that a sharp drop in retention during the first hours after nonsense syllables were memorized. So he came to the discouraging conclusion that most forgetting occurs very rapidly. Fortunately, though, subsequent research showed that Ebbinghaus's forgetting curve was unusually steep, in part because he worked with such meaningless material. Studies of other types of material eventually showed that rapid forgetting is not inevitable. So you could click to see the representative forgetting curve for other type of material here. So if you look at for prose, it's a little bit better, and for poetry, it's even better. So it really depends on what it is that you're trying to remember. The key is meaning. The more meaningful the information is, the longer you're likely to remember it. Okay. Now we're going to talk about some measures of retention in memory. Ebbinghaus's pioneering research demonstrated the need for precise measurement of retention. Retention refers to the proportion of material remembered. Imagine that you memorize a list of 25 words. There are 3 methods that can be used to assess your retention of this material: recall, recognition, and relearning. I'm going to click on each one of those to show you what they are. So recall is a measure of retention that requires subjects to reproduce information on their own without any cues. If you were to take a recall test on the list of 25 words you had memorized, you would simply be told to write down on a blank sheet of paper as many of the words as you could remember. Recognition. A recognition memory of retention requires subjects to select previously learned information from an array of options. For example, you might be shown a list of 100 words and then asked to choose the 25 words that you had memorized. So that would be more like a multiple choice test, and a recall would be more like an essay test. And then finally, relearning. Relearning is a measure of retention that requires a subject to memorize information a second time to determine how much time or how many practice trials are saved by having learned it before. Subject saving score represents an estimate of their retention. So you learn it once, and then they test you after you learn it a second time to see how well you remembered it. and that's what they mean by relearning. So 2 of the 3 approaches to measuring retention have parallels in testing. So if we look, multiple choice tests would be recognition, because you have to recognize the right answer. Essay tests would be recall, and then relearning really doesn't have any parallel in teaching. So if you're like most of my students, you probably prefer multiple choice tests over essay tests. The preference is understandable because evidence shows that recognition measures tend to yield higher scores than recall measures of the same information. So let's see. Okay. Let me think of a study. So there was a study done, I believe it was in the early 20s, that measured subjects' retention of nonsense syllables. I'm going to click on the measure of retention to see the results for recall and then recognition. So as you can see, the memory was much better for the recognition than for the recall. And that sort of makes sense if you think about it in today's parallels. Students tend to do better on multiple choice questions than they do on essay questions. So if you look at this graph, the subject's performance on the recognition measure was far superior to their performance on the recall measure. In general, recognition tests tend to be easier measures of retention than recall tests. But there is no guarantee that a recognition test will be easier than a recall test. The difficulty of a recognition test can vary greatly depending on the number, similarity, and plausibility of the options provided as possible answers. So to illustrate this, see whether you know the answer to this multiple choice question shown here. Click on the 4th President of the United States. I'm going to say Monroe. It was Madison. Many students find this difficult, so do many professors. Hold on a second. Sorry about that. Okay. I was never much into dead presidents, but let's keep going. Virtually anyone can answer this question because the incorrect answers are readily dismissed. Although this illustration is a bit extreme, it shows that 2 recognition measures of the same information can be dramatically different in difficulty. So the 4th President of the United States, Jimmy Carter in the 70s, Kennedy in the 60s, Truman in the 50s, has to be Madison. Okay, let's see what we got here. Check your understanding of the forgetting curve by clicking on the axis in the graph that represents the dependent variable in the study. So the dependent variable would be the retention or the retention interval. So let's see what we could click on. Check your understanding of the forgetting curves by clicking on the retention interval that yield 45% retention. So let's see, 45% would be here. We'll say about an hour. And then check your clicking on the graph. The highest retention would be here. Okay. Multiple choice testing, we said, is recognition. Let's see what we got now. Okay, so now we're going to talk about ineffective encoding and something called decay. So measuring forgetting is only the first step towards explaining forgetting. Why do we forget? Much forgetting may only appear to be forgetting. The information in question may never have been inserted into memory in the first place, a phenomenon called pseudo-forgetting. For example, this is the penny question that you saw from the other video. People usually assume that they know what a penny looks like, but most have great difficulty selecting the correct penny from this array because they actually have failed to encode the information. Pseudo-forgetting usually reflects ineffective encoding due to lack of attention. That's why you could be in a class but still not remember anything from the class because you weren't really paying attention while you were there. But what about material that clearly has been encoded, stuff you really did remember? Decay theory proposes that forgetting occurs because memory traces, that's the biology of memory, fade with time. The assumption is that decay occurs in the physiological mechanisms responsible for memory. If decay theory is correct, the principal cause of forgetting should be the passage of time. Evidence suggests that decay does not contribute to the loss of information from the sensory and short-term memory stores. However, the critical task for theories of forgetting is to explain the loss of information from long-term memory. which does not appear to be due to decay. In studies, though, of long-term memory, researchers have found that the passage of time is not as influential as what happens during the time interval. This was first shown in an experiment, I believe in 1924, by two researchers named Jenkins and Dallenbach. Their subjects memorized a list of nonsense syllables and were tested for recall after 1, 2, 4, or 8 hours later. The catch was that half of the subjects slept during the retention interval, and the other half went out and did their normal waking activities, whatever it is they do. So I'm going to show you what happened for the two groups. For the subjects who slept, retention was pretty good, actually. And for the subjects that didn't sleep, who were awake, the retention was much lower. What does that mean? So the subjects who remained awake forgot more than those who slept. The question then is why? The greater forgetting was blamed on the interference from competing information that they had to process while awake. So if you try to remember something and go right to sleep, there's nothing that's going to interfere with that memory. So many subsequent studies have shown that forgetting depends on not the amount of time that has passed since learning, but on the amount, complexity, and type of information the subjects had to assimilate during the retention interval. The negative impact of competing information on retention is called interference. So let's talk a little bit about interference. So this idea of interference theory proposes that people forget information because of competition from other material. Hundreds of studies have shown that interference influences forgetting. In many of these studies, researchers have controlled interference by varying the similarity between the original material given to subjects and the material studied in the intervening period. Interference is assumed to be greatest when interfering material is most similar to the test material. Decreasing the similarity should reduce the interference and cause less forgetting. The hypothesis was investigated by two researchers in a study that I believe was conducted in 1931. They had subjects, how I remember that, they had subjects memorize a list of adjectives. Then the participants memorized one of the 5 lists in order of decreasing similarity to the test material. They were synonyms of the test words, antonyms of the test words, unrelated adjectives, nonsense syllables, and numbers. Here's what they found. So for synonyms, relatively low. Antonyms, a little bit higher. Unrelated adjectives, nonsense syllables, numbers, and nothing. So it shows the more the material is related, the more likely you're going to have interference. So they found that the similarity of the intervening material decreased the amount of forgetting, also decreased because of the reduced interference. Now, there are 2 kinds of interference. This is a little tricky. Students tend to have a little bit of a problem with this. There's retroactive interference and proactive interference. I'm going to explain each one to you. So retroactive interference occurs when new information impairs the retention of previously learned information. Retroactive interference occurs between the original learning and the retest on that learning during the retention period. So an example of retroactive interference would be when studying of psychology gets sort of interfered with by your study of economics. And then we'll look at proactive interference. In proactive interference, previously learned information interferes with the retention of new information. So in proactive interference, the idea is that the interference is rooted in learning that comes before exposure to the test material. So the psychology information would interfere with your memory for the economic information. That's an example of proactive interference. So it's the old interfering with the new. In retroactive, it's the new interfering with the old. Okay, let's see what we got here. If you memorize a list of numbers, what intervening learning material would produce the greatest interference? Probably be numbers. Clicking on the data that represents the highest retention, that would be here. Most interference would be the synonyms. Which theory proposes that forgetting depends on the passage of time? That would be decay theory. Okay. Now, the last thing we'll talk about is something called retrieval failure. So, people often remember things that they were unable to recall at an earlier time. This suggests that a great deal of forgetting may be due to breakdown in a process of retrieval. Retrieval failures are more likely when there is a poor fit between the processing done during the encoding and the processing used during the retrieval. The concept of the encoding specificity principle states that the value of a retrieval cue depends on how well it corresponds to the memory code formed during encoding. This principle provides one explanation for the inconsistent success of retrieval efforts. Many years ago, Sigmund Freud, whose name we talked about before, came up with an entirely different explanation for retrieval failure. Freud asserted that people often keep embarrassing, unpleasant, or painful memories buried in their unconscious. Basically, in Freudian theory, this was called repression, and it refers to the idea of keeping these uncomfortable thoughts and feelings hidden from you. Now, recent studies suggest that people don't remember anxiety-laden material as readily as emotionally neutral material, just as Freud proposed. That said, repressed memories are highly controversial in modern psychology. A lot of the Freudian stuff is still real controversial. All right, on that note, we are done with this topic on memory, and we are done with Unit